Reciprocal of a polynomial function. I'm Anil Kumar, and here is an interesting question. It says, explain if the following statements are always true, sometimes true, or never true. There are two statements given. The first one, domain of a polynomial function and its reciprocal are same. Is it always true, sometimes true, or never true? Second statement is, range of a polynomial function and its reciprocal are same. Is it always true, sometimes true, or never true? You can pause the video and then look into my suggestion. Well, we are dealing with polynomial functions. Why not to sketch some and then we can draw our conclusion, okay? So we will sketch three of these functions. We know if we have an odd function, it goes to opposite ends. So any odd function will kind of go like this, correct? If it is an even function, it goes to the same end. So it may be kind of like this. Now in both these cases which we have seen, the domain has x-intercepts, and since domain has x-intercepts, the reciprocal will have what? Reciprocal have vertical asymptotes at these points. So those points in the domain will not be there in the reciprocal function, right? So their domains are not always same, correct? But the question is, can they be ever same? That's interesting. How about a graph something like this? Now that is also representative of a polynomial function, even degree, and there is no x-intercept. So sometimes true, there is no x-intercept, and therefore there is no restriction on domain on the reciprocal of this function. The reciprocal of this function could be something like this, right? Yes, and therefore for the first one, domain of a polynomial function and its reciprocal are same. This statement is in fact sometimes true, right? So we can write this as sometimes true. And the example is right there for us. Now the second statement, range of a polynomial function and its reciprocal are same. Will it ever be true? Now in these cases, we know one thing. The end behavior is that when the function approaches infinity, the reciprocal function approaches 0, right? But it is never there. It is never there. So we have a horizontal asymptote. So that puts a restriction. So for a reciprocal function, we are always going to have horizontal asymptote. It may not be at this point, but maybe somewhere else. For example, in some cases, correct? Now, how do you say that? So you can see here, we have, in this case, we have a range which is greater than some value. So in this case, what is happening to the range of the reciprocal function? It is also greater than some value, right? But it is less than some value. We have a local maximum in the reciprocal if we have local minimum in the polynomial function. If we have the otherwise situation, that is kind of a function, let us say like this. In that case, what do you expect? In that case, we expect that the reciprocal function will still have, here we have a maximum, so it will have a minimum, right? Somewhere like this, but behavior will be kind of like that. So their ranges are always different, correct? So this one, range of a polynomial function and its reciprocal are same, is never true, okay? So that is never true. I hope with this example you clearly understand why domain can sometimes be true but not the range. I hope that helps. Thank you.